Professor Jocelyn Bell Burnell.
A little bit about pulsars today, just to bring it up to date. Then I'll talk about some of the occasions when pulsars were nearly discovered, but weren't. And finally, a couple of slides where I pull out, in a very subjective manner, the factors that I think led to the discovery, when and how it happened. When I arrived in Cambridge to be a graduate student, I got given a pair of wire cutters, 2 pairs of pliers, and a screwdriver. This doesn't happen to radio astronomy grad students today. No? No, you have the telescopes already built. But it indicates the kind of work we were expected to do. The analogy is, if you want to take a photograph of some traffic lights, I don't know why you want to photograph traffic lights, but if you want to photograph traffic lights, if you take a long exposure, you see the red light half bright, the amber light half bright, and the green light half bright. If you want to see the pattern of flashes, you must take many short exposures with your camera. Similarly here, if you want to follow this fluctuation, you must have short integration times, short exposure times. And this shows what a time constant or exposure time of 1 second would look like. We, in this observation, used 1/10 of a second, so we could track the scintillations. We could see the fluctuations very well. And that also is important for the discovery of pulsars. This is a little bit of the chart around the date when, with hindsight, we realized we first saw the pulsar. This is the pulsar, and this is some low-level, man-made interference. For those who are interested, it's at 1919, this pulsar. In the early days we called it Cambridge pulsar, 1919. We're not allowed such partisan labelling these days. And maybe you can already see that these two look a little bit different. Here, the spikes are quite spaced out. You can see chart paper between the spikes. Here, they're much more closely packed. And you can see possibly that it's a little bit over a second. It's about 1 1/3 seconds. And when the transit was finished, I got the paper off the paper chart, I spread it out on the floor, and I went along with a measuring tape and checked that they were equally spaced. And that bit of sky was due to transit at about 2 o'clock in the morning. So the charts got scooped up, dumped on my desk, and I ran out of the laboratory, went out to the observatory at 2 o'clock in the morning, and set the fast recording for this bit of sky, and it came blip, 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 1 1/4 seconds apart. Similar to 1 1/3, but not identical, just sufficiently different to be good, and from a totally different bit of the sky. You do not have 2 lots of little green men on opposite sides of the sky, both deciding to signal to planet Earth, which is not an obvious source of light, using a crazy frequency of 81 megahertz and a really